Good afternoon, ma'am. I am Linhart G. Zabico, and I will be presenting to you my product, which is Luncheon Meat Spam. Spam is a brand name for a canned meat product that was introduced in 1937 and is composed of ham, pork, salt, flavorings, and preservatives that are mixed and cooked under vacuum pressure. Because it is heat sealed within the tin, unopened cans can be stored at room temperature and have an indefinite shelf life. Spam is considered as an important protein source that is also cost effective. Spam's main ingredient is chopped pork shoulder meat mixed with ham. Approximately 90% of spam is made from pork shoulder. The remaining 10% or so comes from ham. A whole luncheon meat contains 35% lean meat, 24% fat, 35% water and ice, and 10% powdered additives such as phosphate, nitrate, ascorbate, soy protein, and fillers such as starch and cereal binder, as well as 2% salt. The product is cooked in a hot water bath or with steam at 76 to 80 degrees Celsius until it reaches a core temperature of 70 degrees Celsius. The process for the meat of spam, pork shoulder, and ham is deboned using powerful hydraulic press. Empty spam cans are pushed into the mixers one layer at a time from pallets. Each spam can contain 1,000 pounds of raw ground spam. In a massive hydrostatic cooker, the cans are heated, sterilized, and washed and cooled. After that, they are sealed and ready for labeling. The target market consists of all establishments whose products are primarily focused on food innovations. The processing technologies applied are thermal processing or canning. It's one of the meat preservation methods used. Canning entails sealing meat in a container and then heated it to kill any microorganisms that could cause food spoilage. Cans can be safely stored at room temperature indefinitely under normal conditions. Certain quality concerns, on the other hand, may compel processors or vendors to recommend an optimal sell by date. Intrinsic parameters consist of number 1, natural preservative present in luncheon meat. Luncheon meat contains sodium nitrite that act as a natural preservative. 2, nutrient content present in luncheon meat. Spam luncheon meat consists of 415 to 741 grams of salt and zero point 0.8 to 0.12 grams of sugar. Contents act as natural preservative. And 3, oxygen. If once a can is opened, it has to be consumed within days. The oxygen will affect the product by changing its color from red into gray and green and cause oxidation and rancidity of fats with undesirable off flavors. Whilst extrinsic parameter, our first temperature is over 100 degrees Fahrenheit is in storing. The risk of spoilage jumps sharply as storage temperature rise. At prolonged storage temperature above 75 Fahrenheit, nutrient loss in canned foods increase. And second, canning. Canning entails sealing meat in a container and then heating it to kill any microorganisms that could cause food spoilage. Cans can be safely stored at room temperature indefinitely under normal conditions. The physical-chem characteristics of luncheon meat, specifically spam, are the following: the moisture content, crude protein content, crude ash content, and pH content of canned meat must not be less than 60%, 90%, 3.8%, and 5%, respectively. The product concept for luncheon meat is heating process to ohmic heating. Ohmic heating, also known as joule heating, electrical resistance heating, and direct electrical resistance heating, is a process of heating the food by passing electric current. In ohmic heating, the energy is dissipated directly into the food. According to study, ohmic heating may be used to heat food internally by passing an electric current through it, thereby reducing potential thermal abuse of treated product, unlike conventional heating, where slow heat penetration occurs. The advantage of ohmic heating include better product quality, less cooking time, lower capital cost, better energy efficient, and also that it is an environment friendly process. According to Fryer et al., it requires lower capital costs compared to other electroheating methods. It also has an advantage over microwave processing, where processing can be limited by the depth to which energy can penetrate the food material. Thank you for listening. That is all.